Welcome dear students. In the chapter 5 playing with numbers, we are continuing the video in this part. Now we are at the topic divisibility rule, and the divisibility is the meaning of divisibility. Divisibility means that after dividing there will be no remainder. When we divide any number, then and no remainder is left, it means number is completely divisible. Let us go check the divisibility of 85 by 5. We divide 85 by 5, and here 5 into 1 5, and then 5 into 7 35. Remainder is 0 at last, so 85 is completely divisible by 5. Check one more. 144 divisible by 4 or not. Look at the division process. When we divide 144 by 4, 4 3s are 12 at the first step, and then 4 6s are 24 in the second step, and at last we have 0. So it is completely divisible by 4. These are the checking method, divisibility checking method by dividing. Further we will study without dividing how we can come to know that the number is divisible by 2, 3, 4, etc. or not. When we have a larger number, again we have to divide. It will be a very lengthy process. So there are some divisibility rules for checking the number whether it is divisible or not, and we are going to study about these divisibility rules. Divisibility rule is a way of determining whether given number is divisible by a fixed divisor without performing the actual division. Without performing actual division process, we can examine whether the number is divisible or not. And what we have to examine? We have to examine its digits, last 2 digits, unit place digits, and odd place digits, even place digits like this. Now we are moving for the divisibility test by 10, 5, 2, 3, 9 and 11. First we come to the divisibility test by 9, and for this the unit place should be 0. Let us see. A number is divisible by 9 if it has 0 at the ones place. Ones place means unit place. Example, here both numbers have 0 at the ones place, so they are divisible by 10. Any number CBA can be divisible, written as dash 100C plus 10 100B plus 8. This is the explanation. And this is the complete explanation. As far as A is concerned, it must be divisible by 10, so it should be 0. And the given number is divisible by 10. This is possible only when A is 0. So in this divisibility rule, for the 10, the unit place, ones place should be 0, which is A here. Come to the next divisibility rule, that is by 5. A number is divisible by 5 if the unit place digit has 0 or 1, means ending digit, last digit is either 0 or 5, then it will be divisible by 5. Let us see some examples. 965, unit place is 5, divisible by 5. 320, unit place digit, one digit is 0, so it is divisible by 5 again. Now there is the explanation. CBA is a number, and 100C plus 10B plus A is the usual form of this number, and 10, 100 are divisible by 10 So are 10B, 100C, which in turn are divisible by 5 because 10 is 2 into 5. As far as A is concerned, it must be divisible by 5 if the number is divisible by 5. So A has to be either 0 or 5. Now next is the divisibility rule by 2, and for this the unit place digit should be even. Even means unit place digit should be either 0, 2, 4, 6, 8, etc. If unit digit is 9, so it is not divisible by 2. Let us see some examples. If 470, 176, like here all the numbers have even digit at the unit place, so they are divisible by 2. 0, even, 6, even, 0, even, 6, 4, even, 2 is also even, 8 is also even. So rule is that one's place digit should be even for the divisibility by 2. Explanation. CBA is a number. In usual form, it is written as 100C plus 10B plus A. Now, first two terms, 100C plus 10B are divisible because 100 is divisible by 2 and 10 is also divisible by 2. And when A is divisible by 2, then the complete number will be divisible by 2, and this digit A is divisible by 2 for even digits only, which are 0, 2, 4, 6 or 8. And next is the divisibility rule for 3. This is very different rule, and here we have to check the sum of the digits of the number. If the sum of digits of the number is divisible by 3, then the complete number is also divisible by 3. For 276, 2 plus 7 plus 6, sum of the digit is 15. 15 is divisible by 3. So 276 is also divisible by 3. 822, sum of the digits is 8 plus 2 plus 2, which is 12, and 12 is also divisible by 3. So 822 will also be divisible by 3. In the same way, next number 4590, sum of the digit is 18, which is divisible by 3. So the complete number 4590 is also divisible by 3. Now explanation. 3-digit number taken as CBA, which will be 100C plus 10B plus A. Now it is written as 99C plus 9B plus in the bracket A plus B plus C. 1A from 100 and 1A from 10 is taken out, and this A is added. Then 9 is common taken, 11C plus B, and here we have A plus B plus C. Now this is divisible by 9, which means it is also divisible by 3. And then if A plus B plus C is divisible by 3, then complete number will be divisible by 3. So sum of the digits should be checked for the divisibility of 3. There are some problem questions. Is 343 divisible by 2? Unit place is 3, so it is not divisible. The digit at unit place is not multiple of 2, so 343 is not divisible by 2. Now, 165 divided by 10, unit place it is not 0, so again it is not divisible by 10. Here, 4580, unit place for divisibility by 5 should be 0 or 5, and here unit place digit is 0, so it is divisible by 5. Is 15 divisible by 2? Unit place digit is odd, so it is not divisible by 2. But it is also divisible by 3 because some of the digit is divisible by 3. But here we are asked for both. So 15 is not divisible by both 2 and 3. It is only divisible by 3. Coming to next rule, divisibility by 9. Again, same rule like 3. A number is divisible by 9 if the sum of its digits is a multiple of 9. There are some examples. 2 plus 1 plus 7 plus 1 plus 6 plus 1. When we add all these digits, then we have 18. Then 18 is divisible by 9. So this complete number 2,17,161 is also divisible by 9. And we can also say, in other words, it is a multiple of 9. In the same way, the second number 4,25,490 also divisible by 9. The sum of the digits is 27 here. Let us take our 3-digit numbers in the explanation for divisibility by 9. Number is written in the usual form. 100C, 10B plus A, 100 place, 10's place, 1's place, and then 99C plus 1C, 100C, 1C is taken separately, and 10B is also taken as 9B plus 1B, so 1B is taken separately, and then 9 into 11C plus B, and if we are left with only A plus B plus C, which is shown here in the yellow color part, and if A plus B plus C is divisible by 9, then the complete number will be divisible by 9, because the rest of the part is already divisible by 9. In the same way, we have other example also, solution here. Now in this part of video, we are beginning with the divisibility rule for 11 up to divisibility rule for 9 we have done in the earlier part. Let us see. A number will be divisible by 11 if the difference between the sum of digits, here we have to find out the sum of digits in two ways. First, the sum of digits at odd places, and secondly, the sum of digits at even places. After finding the sum of both types, odd place and even place, then find their difference. If their difference is 0 or any multiple of 11, then the complete number will be divisible by 11. Let us go through the example now. Here we have a number 15,972, and we have to check whether it is how it is divisible by 11. And here from right hand side, 2 is at first place, so it is odd, 9 odd and 1 odd. So the sum of the digit at odd places 2 plus 9 plus 1, which is 12. Then left over digits are at even place, which is 5 plus 7, and that their sum is also 12, and the difference is 0, and 12 minus 12 0, and therefore the number 15,972 is divisible by 11. Next, one more example, 50,413. Here the digits at odd places are 3, 4 and 5. Sum is 12, and the digits at even places are 0 and 1. Sum is 1, and the difference between both sums is 12 minus 1, which is 11, and 11 is multiple of 11 itself, and therefore the number 50,413 is divisible by 11. Now there is an explanation. We can write the three-digit number ABC as 100A plus 10B plus C. This is a common denotation of the three-digit number: 100 place, 10's place, 1's place. Then these are splitted. 100 is split as 99 plus 1, so 99A plus A. 10 is split as 11 minus 1, 11b minus b, and c as it is. So 99a plus 11b plus within bracket we have a minus b plus c, and then 11 is taken out common and 9a plus b is left over, means this part is multiple of 11. If this is also multiple of 11, then the complete number will be divisible by 11. Means sum of odd minus even is a multiple of 11 or 0, then the number will be divisible by 11. One more example, and this example is for 4-digit number 1000a plus 100b plus 10c plus b, and again it is split 1001 minus 1, 1000 is split as 1001 minus 1, 199 plus 1, and 10 is 11 minus 1, and d as it is, and then 11 is taken out common, and within the bracket we are left with 99a plus 9b plus c, and on the other part we are left with b plus d minus a plus c. Here b and d are the sum of the digits at odd places, and a and c are the sum of digits at even places. So if sum of the digits at odd place minus sum of digits at even place. This is the difference of both the sums. If this difference is divisible by 0 or 11, then the number is divisible by 11. Now can you list 3 numbers that can be multiplied to make 150? You have to find out the factor of 150. Here factors of 150 are 2, 3, 5, 6 and 10, and in the box we have to write down the 3 numbers. To pick any one number from the first box and then multiply rest of the 2 numbers, and then again multiply last 2 numbers. 2, 15 and 60. 2, 15 and 60. So let us see the example. 150 divided by 75. 2 is written here, then 75 will be divided by 5 further. Oh, sorry, it is divisible by 3 also, so it is divided by 3 here, which is 25, 3 into 25. 75 is written as 3 into 25. So the product of 150 in 3 number is 2 into 3 multiplied 25. Numbers can be written in general form. This is a general form. AB is 10a plus b. Thus a 2-digit number AB will be written as AB equal to 10a plus b, and 3-digit number will be written as 100a plus 10b plus c. Sum of a number and the number after reversing its digit will always be multiple of 11. When you add the sum of the digits of a number, and then when you reverse the number and you add both the numbers, then that addition sum will always be divisible by 11. There will be explanation also. A number is divisible by 2 if it has any of the digits 0, 2, 4, 6, 8 at its one place. Divisible by 3 if sum of digits is divisible by 3. And divisibility by 5 if unit place digit, ones place digit is either 0 or 1. 5. 0 or 5. A number is divisible by 10 if at ones place we have 0. And for divisibility rule, just like 3, the sum of digits should be divisible by 3, then the complete number will also be divisible by 3. And for 11, we have to find the difference of the two sums, sum of odd digits and sum of digits at even places, and that difference should be 0 or multiple of 11, then the complete number will be divisible by 11. Okay, thank you. not given in your book. This is separately for you. And number taken is 882, and we check how it is divisible by 7. First, we will select the last digit, which is 2 here, and we will make the twice of this digit, which is 4. So 2 into 2, this is 4, and then we subtract 4 from the remaining part. Remaining part is 88, and we subtract 4 from 88, we get 84 now, and again now we will go to the same step. Now we will select the last digit again, which is 4, and multiply it by 2, that is 8, and now we subtract this twice of the 4 from the remaining part. So 8 minus 8 at last, finally we will have 0. If going through this process we ultimately arrive at 0, then it means the number is divisible by 7. Here 882 is divisible by 7 because at last we have arrived at 0. We can check this value. We can verify it by dividing. This is the verification only. Seven minus 7, 1 remainder, 8 brought down. We have 18 now, 7 to the 14, again subtracted, remainder 4, and this time 2 is brought down, 42, so 7 6 are 42, means this number is completely divisible by 7 because remainder is 0.